Okay, today I'm going to be teaching you about exponential growth functions, okay? We really haven't done anything similar to this yet. Remember, the only thing we've done so far is we learned how to graph y equals mx plus b, okay? And what was important here was that the power of x is 1, right? Now, in a few days, we're going to get into this. We're going to get into things like x squared plus bx plus c, okay? Where x is squared. But today, we're going to actually say what happens when x is the power, okay? And we're just going to do a real simple problems today, which is just graphing them to see what they look like, okay? First things first, when you see an equation like this, when you see x is the power, the first thing you want to do is realize that it's going to do something like this. It's going to start real small and get really big quickly, or it's going to start really big and get really small quickly. We're actually going to talk about that other one tomorrow. But it's either going to start small, get big quickly, or start big and get small quickly. All right? And this one, what you can do is you can tell that when the b number, whatever this number is, when it's greater than 1, it's going to start small and get big. Okay? So the best way to do this is just to do a few problems. Remember, this is going to be x, and then I'm going to put in what 2x is, kind of like an input-output. And I need to put in a group of numbers. I'm going to put in 2 negatives and 0 and a positive. So I'm going to put in like -2, -1, 0, 1, and 2. And I'm just going to do the math. 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 to the 2, right? Well, 2 to the -2, remember what that means? That means 1 over 2 squared, which is 1/4. So that's going to be 1/4. That's going to be 1/2. And you need to check back on that lesson on negative exponents to understand what I just did there. 2 to the 0 is 1. Remember, anything to the first power is 1. 2 to the 1 is 2, and 2 squared is 4. Right? All right, so all I have to do then is just graph those points. -2 was 1/4, which is about right there. And -1 is about a half. -1 is about a half, so it's about right there. And 0 is 1, so it's about there. And 2 is 1. Sorry, 1 is 2. 1 is 2. And 2 is 4. So you can see what's happening. These are really hard to graph because it's really hard to draw this curve. And it's going to be really hard for me to draw this curve on with this computer program. I'll do the best I can, but you're going to have to really try to make sure it gets smoothed out, okay? And also, it might be a good idea to try a couple more numbers just so you know how fast it's curving. Because you do know that it's going to curve up now, but you don't know how fast it's going to curve up. If you put 3 in, what's going to happen? Well, that'll be 2 to the 3rd, which is 8. So it's actually going to be up here. So now you got a really good feel for the curve, right? And I'm going to try to draw this in. Now, before I draw this in, I want you to understand something. This line never gets below the x-axis. This line that I'm about to make never gets below the x-axis. It gets closer and closer to the x-axis, but it never actually touches it. And let me explain to you the logic behind that. It's a lot easier to see on a calculator, which I don't have with me right now. But if you had a calculator and you started putting these numbers in, you would see that it would, if you put a -2 in, right, you would get 1/4. If you put a -3 in, you would get 1/8. The next time you'd get 1/16. Then you'd get 1/32. Then you'd get 1/64. Right? It would keep getting smaller and smaller and smaller. Right? 1/64 is a very small fraction. Another smaller fraction, smaller and smaller. Every time you're cutting it in half is what's happening. But every time you cut something in half, you still have some. If you start with any amount and you just start cutting it in half, you'll always have something. You'll never have 0. Now, it'll get really close to 0, but it'll never actually touch 0. So that is something you need to keep in mind. When you draw your graph in, Never actually let it touch the x-axis. Something like that, right? And you're going to have to forgive me on that. You want to make it as smooth as possible, but it'll look something like this. It'll never fall below the line, okay? Now, there are exceptions to that, but we're not going to get into them today, okay? All right, so let's do another example. So that's what this looks like. Oh, forgot something. In a couple days, sorry, lost my page. In a couple days, we're going to be doing some other things with this. But right now, I'm going to show you something that I want you to write. It's not going to make a lot of sense to you right now. But if you start writing this now, by the time we get to the harder thing in a couple days, by doing what I'm about to ask you to do right now, it's actually going to make it easier, okay? So just kind of stay with me here. All right, we started off, our equation was y equals 2x, okay? Or 2 to the x, not 2x, right? I want my equation to look like this. This is the key. I want it to look like this, all right? This t number is going to be my x number, so t is time, so it's going to be x. So in a sense, you can think of the t as the x number, okay? What I want you to do is I want you to write this equation to look like this equation, okay? So here's the first things first. I'm going to write that out so I can see it. Y equals a times 1 plus r to the t power. All right? Now, so this becomes y equals something times the number to a power. If I was to multiply 2x times something, what number would be in front of here? Well, hopefully you see a 1. So it'd be 1 times. Yeah? And then, now this is the part that people have a little bit of trouble with. I know that's going to be x, right? T, the power of the power. What I need to do is, it needs to look like 1 plus something. Right? So here's all you do. You know that the power number is 2. So 1 plus what gives me 2? Well, obviously it's 1. So this is going to have to be 1. Now let's check this out real quick to make sure you understand this. 1 plus 1 is 2, so there's my 2. 2 to the x. 1 plus 1 is 2, 2 to the x. This 2 to the x is the same as 1 times 2 to the x, so I can put a 1 there. Okay? So what is my a number? 1, because a is 1. What's my rate? My rate is 1. And my t is x. Now, this is going to make no sense to you right now. You're going to be like, why the heck would I do this? But in a couple days, if you get used to writing this now, in a couple days, that assignment's going to be a lot easier for you. So just trust me right now. Every time you get an equation, I want you to write it in exponential growth formula form, okay? Because if you do that, life's going to get a little bit easier. All right, so let's do another example. All right, remember what we're going to do here. X goes here. The equation goes here. Right? I'm going to do -2, -1, 0, 1, and 2. So I'm going to have 3 times 2 to the -2, 3 times 2 to the -1, 3 times 2 to the 0, 3 times 2 to the 1, and 3 times 2 to the 2. Figure out what that is. 2 to the -2 is 1/4, so that's 3/4. 2 to the -1 is 1/2, so that's 3/2. 2 to the 0 is 1, so that's 1. 3 times 1 is 3. 2 to the 1 is 2. 2 times 3 is 6. And 2 squared is 4 times 3 is 12. So there's my numbers, right? And I just graphed those. -2 is going to be 3/4, so about right there. -1 is going to be about 3/2, which is 1.5, about right there. 0 is 3, so it's here. Right now it looks straight, but it actually isn't, okay? 1 is 6, see that? It's getting big really quick. And 2 is 12, which is off my paper already. And remember what I said, it's gonna curve, but it never gets below 0. So that's what I'm going to do. I'm going to make it kind of look like it's close to 0, but not on 0, and then it curves up. And you kind of want to smooth that out as much as you can, but that's the idea behind it. Okay? It looks something like that. Once again, why does it not get below this x-axis? Because each time I go down, I'm going to divide it by 2 again, divide it by 2, divide it by 2, and each time I divide something by 2, I don't get 0. I never get 0. I always have something left, so it's going to get closer and closer to 0, but never actually touch 0. Okay? Then I need to write it in standard form for growth equations. A times 1 plus r to the t. Okay? So I get y equals 3 times 1 plus what makes 2? 1 plus what makes 2? Well, it has to be 1 to the x power. Got it? So what's my a number? My a is my initial amount. It's 3. What's my rate? It's 1. And my t is x. Okay? All right, let's do another example. Start off with x, and this is going to be negative 2 times 3x. And I'm going to do negative 2, negative 1, 0, 1, and 2. So this is going to be negative 2 times 3 to the negative 2. This is going to be negative 2 times 3 to the negative 1. This is going to be negative 2 times 3 to the 0. Negative 2 times 3 to the 1, and negative 2 times 3 to the 2. All right, so let's do the math here. 3 to the negative 2 power is 1/9. So this is going to be 1/9 times negative 2, okay, which is negative 2/9. You can use a calculator for this if you want, okay? 3 to the negative 1 is 1/3, so that's negative 2/3. 3 to the 0 is 1 times negative 2 is negative 2. 3 to the 1 is 3 times negative 2 is negative 6. 3 squared is 9 times negative 2 is negative 18. So here's something different. When I start graphing this one, every graph I've done so far starts small and gets big, okay? This time you're going to see that this curve actually does this. Because when I negatize this, when the a number is negative, it actually takes that graph and it flips it to the opposite. So think of a reflection of this line across the x-axis. So it's actually going to look like this in some way. So it's going to curve the other way. Does that make sense? So when this number's negative, it's going to start small and get big, but in the negative direction. And when you graph this, that'll make sense. So let's graph these points. Negative 2 is negative 2/9, which is around there, I guess, right? Negative 1 is negative 2/3, which is here. 0 is negative 2. 1 is negative 6. And 2 is off the chart. It's way the heck down here somewhere. But as you can see, there's my curve again, right? It's going to curve like that. And it is really hard to graph these on this tablet, but I'll try. So it starts like that. And then it gets like that, right? Wow, that is a really bad job. But something like that. I'll clean it up a little bit here. So something like that, right? But notice, once again, it never actually touches 0, because each time I go below negative 3, negative 4, I get closer and closer to nothing, but I never actually get nothing. Okay? Let's do the standard form. Y equals a times 1 plus r to the t. Okay? Y equals negative 2 times 1 plus what makes 3? 1 plus r made 3. So what does r have to be? Well, not 3, 2. 1 plus 2. 1 plus 2 makes 3, right? 1 plus 2 makes 3 to the x. So my initial amount is negative 2. My rate is 2. and t is x. Okay? Last example, I believe. Yep. All right, one more example. Let's just do the same thing again. Here's x. Here's negative 1/2 3x. Negative 2, negative 1, 0, 1, and 2. This will be negative 1/2 times 3 to the negative 2, negative 1/2 times 3 to the negative 1, negative 1/2 times 3 to the 0, negative 1/2 times 3 to the 1, and negative 1/2 times 3 to the 2. Okay, let's do the math. 3 to the negative 2 is 1/9. Negative of 1/9 is going to make it negative, so that's going to be negative. 1/2 times 1/9 is 1/18. Real small number. Like I said, you can do this on a calculator if you need to. 3 to the negative 1 is 1/3. Half of 1/3 is 1/6. So this is negative 1/6. 3 to the 0 is 1. 1 times negative a half is a negative half. 3 times negative halves is negative 3/2. And 9 times a half is negative 9/2. Okay, so let's graph these. Negative 2 is negative 1/18, so it's very close to the line. 1 is 1/6, so it's really close to the line. 0 is a half, so it's here. 1 is 3/2, so 3/2 is 1.5, so it's here. Oh, just screwed that whole thing up, didn't I? Every one of those was negative, so let's start over again. Pretend that didn't happen. Negative 2 was negative 1/18, so it's here. 1 is negative 1/16, so it's about here. 0 is 1/2, so it's here. 1 is negative 3/2, so it's here. And 2 is 9/2, which is 4.5, so it's here. So it's doing something like this. It's curving like this, right? 27 over 2. I'm trying to see how fast it's going to be way off the graph. All right, then I get to try to sketch this thing. So it's going to look something like this. Something like that. And I'm going to clean it up a little bit. But something like this. There, that's not too bad. Right? Last thing to do is write it in standard form. A times 1 plus r to the t. The initial amount is negative a half. 1 plus what makes 3? 2 to the x power. A is negative a half. B is, I'm sorry, not B, R is R is 2, and T is X. And there you have it. Exponential growth equations start small and get big. When you see graphs like this or the reflection of that graph, you know it's a growth equation. On the next lesson, I'll be teaching you about decay. But it's a pretty simple concept, and if, worst case scenario, you could graph it and see what it looks like, but you have a pretty good idea about what these look like now. All right, good luck.